Okay, so we've got this function here. F of x equals 3x take 9 over x squared take x take 2. We're told that there's a local minimum at this point here, and we had to find the derivative. Actually, the original question said show that the derivative equals something, but essentially what we're going to do is find the derivative. Okay, so we'll look at the function here, and what you notice is that there's actually two ways you could do this. The most obvious way, which is the one that we'll use, is the quotient rule, because we've got one function on the top and one function on the bottom, so numerator and denominator, and we can use the quotient rule. So the quotient rule goes like this. So if we've got a function y equals f of x divided by g of x, then the derivative, it's similar to the product rule with a minor variation. So the derivative of the first times the second minus the first one times the derivative of the second divided by the second function squared. So that's just from the formula sheet. So all we have to do is apply that here. So we go f primed x equals derivative of the first, which is 3 times the second, minus the first one times the derivative of the second, which will give us 2x minus 1, and all of that's over this bottom function squared. Okay, so now it's just a matter of multiplying it out and simplifying it. So we got 3x squared take 3x take 6, subtract, what do we got here, 6x squared take 18x take 3x plus 9. Okay, that's all over x squared take x take 2 squared. Okay, so what have we got? 3x squared take 3x take 6. Let's leave that there. So minus 6x squared. This gives you minus 21. So it's a minus there, so that means it's plus 21x. And we've got a minus 9 here. Okay, that's all over the things that we had before, which equals, right, so 3x squared minus 6x squared gives minus 3x squared. We've got minus 3x plus 21x, that gives us plus 18x. And we've got minus 6 minus 9, which equals minus 15. That's all over this same denominator. Which equals, we can bring a 3 outside. In fact, let's bring a minus 3 outside. So we get x squared take 6x plus 5 over the denominator, which we can simplify or factorize. So what have we got? X take 1, x take 5, divided by, okay, let's put this back in, so we've got a complete answer. Okay, and there's our answer. Okay, now the second part of that question says, using this, determine the local maximum value of the function. Okay, this is where we go back to this information that we've given up here, which was irrelevant until now. We were told there's a local minimum at when x equals 1. So if you look at this function here, which is the derivative, so the local maximum value is the max and the min are when the derivative is 0. So how do you get a 0 from this function? Well, it can only happen, so f of equals 0 when x equals 1 or x equals 5. Okay, now we know that x equals 1 is a minimum because we were told that, so the maximum has to be at x equals 5. And when we plug x equals 5 into the function, so we get f of 5, remember we're plugging into the original function, 3 times 5 take 9, over 25 take 5 take 2, equals, what's 3 times 5? 15 take 9 is 6. 25 take 5 take 2 is 18, so equals 1/3. Okay, so the local maximum, the coordinates are